So, we are continuing the same topic, uh, high bulk yarn, and we will try to wind it up today so the high bulk is concerned. So, what we have learned is that the high bulk yarns can be produced by mixing two fibers which have substantial differential shrinkage. So, the difference between the two should be high, close to 25% or more. Acrylic high bulk yarns are commercial success from this principle, and reason is that the amorphous orientation can be frozen in acrylic fibers, enabling the production of shrinkable fibers. Then we did learn how normally cutting of filaments is done, particularly for producing staple fibers of desired staple length. Also in this we understood that the common method of cutting to staple fibers is basically wrapping the crimped toes onto a rotating roller with projecting knife or blades, and the spacing can be adjusted to suit the suitable length based on whether you are a woolen system or a cotton system. The roller is hollow from inside, so the cut bundles keep falling inside, which can be pneumatically taken to the bale press, and that is how you can take the thing. But then it was understood that a multi-filament yarn which is already parallel, we need not lose, if possible, the parallelized fibers, so that some of the steps could be avoided. That is why the toe to top conversion was considered. So, the advantage, if you think about it, that so it is one of the direct conversion of toe into top or a sliver. In between, we do not have to do much if we can do it. So, the carding and other drafting processes could be avoided. It is expected that the tops of high quality will be there because very parallelized, uniformity is likely to be high, low degree of neps because during carding all those tailing ends and trailing ends and those kind of things may not be there, low short fibers because after this there is no breakage. And during carding and other process there can be breakage of fibers also, you can get short fibers also, and the process is economic and short. And the added attraction is that this process has become popular for production of high bulk acrylic yarns. Although you can make toe to top of polyester, you can make toe to top of polypropylene or whatever you want, but somehow acrylic fiber industry could find good use of this. In fact, large number of them use this method. So, for this toe to top conversion, they use two basic approaches. One is crush cutting, like crush is the word because there is a blade which cuts the fiber, but before cutting obviously there is a crushing. So, this term says crush and cut. So, even if it is a fine blade, but still there is a thickness involved. So, the cutting is by crushing with the help of blades which are helical. We will just see why they are helical. Other is a technique which is called stretch breaking, that like you keep extending till it breaks. So, the difference between the two is the first one, obviously the staple length can be more or less fixed. In the other case, the break can take place in some zone, and therefore, the lengths of each fiber may not be same. But both the principles and machines based on these two are available and which people use. So, a crush and cut converters, so they are called converters, right. So, the whole machine may have many elements other than the cutting system. So, important thing is, after guiding, there are toes, they are supposed to be spread. So, you have so many toes are coming, you spread them on a plate like so, as if only single filament, but it may not be true, there may be more than one, but it can't be a rope kind of a thing. You don't cut into rope, so you will flatten it out. So, on a plate you flatten it down, generally level it before cutting. So, after that is done, you may have a stretching zone. Is optional means that if you are doing a polyester toe, you are not interested in producing a shrinkable, non-shrinkable kind of environment. So, you may not use it. So, normally what will happen is that you have a system, but you may not stretch, like you do not give the differential speed. So, you may not stretch. If there is a heating element, you may not heat, and so just passes. So, that is one thing. Then of course, there is a cutting system which is based on this principle of crush and cut. And after that, once you think it is done, then you have to collect it. Drafting, drawing sections could be to produce slivers or top, as they call in woolen industry. There may be a further crimping for any process, some cohesiveness of the thing. Then coiling head and cans where you actually store them. So, what would happen is that people who are doing this conversion may be the people who are making acrylic high bulk yarns, may not be. So, this may be happening somewhere else, and then you have to supply the top. So, you have a canned top. So, it has to be done nicely, so that when you are able to take it out, drop it down. So, like we do. So, it is possible that you may be transporting this also, depending upon who has interest. Somebody may have interest only in blending with, let us say, wool or polyester. They may not be wanting to do any high bulk shrinkage. But this is how you will be supplying. So, the cans or other packages which may be supplied, so that you can take the sliver out and then do further mixing, blending whenever you want. So, cutting is a spiral blade. So, the blade at the moment, whenever you seen in the normal cutting system, you have a blade, either a blade which is a flat blade arranged in over the circumference of a roll, but here we are looking at a spiral blade. So, maybe one blade which is moving like this. The edge of the blades are fine, but this kind of a dimension. So, 0.3, 0.5 mm, what it means is that will be some crushing will take place. So, when crushing takes place, maybe the edge is not as sharply cut, maybe it is slightly flat and cut, this is possible. But this could be true with any kind of cutting systems. So, here the toes are not of those big deniers, these are the toes which are finally going to be converted to right kind of a sliver or a top. So, this will be lesser in that sense. The filament deniers could be anything, but generally 3 to 6 denier or something similar in Decitex may be there. The way the toes are also carried and brought to the machine, it is expected, maybe they are in the can or any kind of a pack, that when you take them out, there should be no twisting happening, because then you will not be able to spread properly. So, there should not be any twisting, there should remain a twistless material which would be able to be spread, and then you can cut it. So, the helical or spiral blades, So, the cutting roller has helical blades embedded in a synthetic rubber system. So, if this is the roll, so the blades may be appearing, but this whole thing is embedded. So, you have all over, let us say, a rubber which is, so the projection is very small. So, it is not like the blade of this is just jutting out, because it can bend. To support the thing, there is a matrix. The matrix is rubber, which is also flexible. When you press, it can support. But the rubber surface is supposed to give to the rest of the thing where it is not being cut, a gentle treatment, and also restricts slippage, because this toe is passing through some rollers, and if because of some tension, of course, little bit, or anything else, if there is a slippage, then you can have double cuts. You just cut it and again another cut can come, and so very short systems can be say. So, this does a frictional kind of a work as well. The spiral blade ensures continuity of the web. If they were not spiral and if they were arranged like this, then we would also cut. So, you remember we saw another roller time. The blade could be arranged like this on the circumference, and the rubber is here. If that happens, then you will have the cut fiber just falling down. So, if they fall down, then you are actually again collecting as if you are taking it for bale formation, but you are not interested in that. So, in that, if you are not, then the spiral one helps to maintain the continuity of the web. So, the web can actually pass, like you have a sheet of the toes, spread toes moving. When you cut, it would appear as a web is moving, right. So, it is not going to fall down, because each one is overlapping with the other one. Then this kind of a roller obviously would have another roller which may be hard roller, so that the cut takes place, which may be called the anvil roll, and so things will pass through this and support it, and finally the cut row, the toe will pass through the shuffling, debonding because sections before crimping and canning. So, shuffling etc. or debonding may be required, because in case you have, because of spin finish, spin finish had three functions other than the lubrication, static, but also cohesiveness. If there is too much of cohesiveness, maybe few fibers are always getting cut together, while you would be happy if all the fibers are separated out, right. So, therefore, you may do some shuffling, so that if there is a loose bonding between the fiber, they just get loose, so that when you make a sliver out of it and do any kind of a twisting later, it gives you a good result. So, the spread toe is moving in this direction, and here you get a cut, and the cut therefore is going to be not perpendicular to the fibers based on the staple length. So, when the fiber etc. are getting cut, so this fiber, if it is near, obviously I have just drawn it further, but basically you can see if they were perpendicular, then the cut would have been here. So, you have some overlapping area. Every fiber with the next one will have some overlapping area, and so they will hold each other and the web will be formed, and it will not just drop down, which would be in a normal cut, because the blade is, as the blade is rotating, the position of cut is shifting, because this is continuously moving, the roller is continuously moving, right. So, this is the principle of the helical blades, which obviously in the there is a rubber, they are embedded in the rubber whole thing. So, the input quality also, people say, well, if your input quality is bad, that the toes are overlapping with each other and they are not parallel and they are not spread properly, they one is going in this way, the other is going the other way. After cutting, you will get whatever you get. So, it is important that toe shape, whatever they mean, is that continuous filament should be uniformly fed. So, this spreading also, although looks simple, but it may not be simple, you have to spread it properly. There may not be broken ends, because invariably there may be broken ends that can cause either entanglements or push the things out, and then you don't know what you are doing. And tension should also be even. If half the, because sometimes you may be mixing more than one toe, because the platform is big, and if all of them are going in different tension levels, then we can expect something else happening somewhere else. Cleanliness, what it means normally is that there are no fused filaments, undrawn, so melt spinning with the polyester, for example, your POY, if for whatever reason, if the filaments are stuck somewhere, in that situation, you would have those things coming together. It is not just the spin finish part of it, or because of not the presenting of the thing in the right way, you may not have fully drawn, and so these can also get cut, and at high temperature they can diffuse, or the dimensions may be different. So, that is the final top. If it has to be good, this also is expected. See, you may appreciate the normal staple fiber which is cut is cheaper than the filament fibers, because people believe that even if there are variations, they will get mixed and then you will get a uniform shape. In this case, you are finally getting the yarn without any other mixing, and so if you have things which are not so clean, then there can be problems. The lubrication means the whatever spin finish was added, it should, if it is, you obviously want the friction to be less, so that it just moves on. But if you add too much, then you may find cohesiveness is so much that the bundles are actually getting cut together and the bundles are being passed. If the bundles keep getting passed, then the sliver is not going to be as good. That is why they do debonding is an important portion which you will do. A toe packing means that when you take the toe out from whichever bundle that you have, you should be able to take out without inserting any twist. So, even if somebody has done a coiled thing, then suddenly if you take it out, automatically some twist gets inbuilt. So, you have to ensure that the toe as it is coming does not get any pre-twist before cutting. One of the examples is a Pacific converter from the US, which makes this type of machine as well. There are others also. Rieter also, I believe, make toe to top converters. So, a line diagram may look like this. So, you have a toe 1. This, let us say in the case of acrylic, because we were interested in this, can pass through a zone which is stretching. We are in crush cut, so it is not stretching for breaking. It is stretching to produce finally a material which is shrinkable. So, you stretch, there is a heater, so there is a heating element. So, between this and maybe another set of a roll, you have stretch being given, whatever level of stretch that you want to give. And to ensure that this stretch actually has those changes which were said that dipole-dipole interaction will take place. So, molecules get stretched up to that degree and then you cool. So, this can, therefore, this toe can be considered the one which is likely to be shrinkable type. So, one is that you take this toe, cut it and send it, this is a shrinkable fiber, you mix it whenever you want to mix it. Other is that if I am the one who actually making high bulk yarn, say well I will take the other one also which is not been stretched. So, you can have a toe 2 which is not been stretched. So, you have a stretched toe and toe of an unstretched type of a fiber also, and then you can mix them here in the ratio then what you want to mix, 4 of this, 6 of that, whichever way you want, right. So, if you do that uniformly, then you do all the spreading etcetera at this portion and then you do a cutting. So, when you are cutting, so you actually have a mixed toe coming where one of or some of the toes have been stretched and others have not been stretched. So, if this is a situation, then you go and cut. So, your so called web that is coming has got mixture of them. Then you do various types of apron drafting systems could be attached, which may have a shuffling system also, debonding, you may have a little bit of vibrations also. So, that anything, any fiber which are sticking to each other, they may just get debonded. There can be another way, sometimes when a toe comes on a the web comes, you can, if the web is passing in this direction and on the top, if you have a roller which is oblique in the direction and it keeps rotating in this way, this also can do a bit of a debonding because it gives a shear. So, that this kind of thing happen, and after that you do whatever drafting, you satisfy the text and you can do certain things. So, you have an anvil roll and a cutting roll. In case after this you have two types of things, you may not have two and you want to blend with polyester. So, you can have another top coming from somewhere else and that can get mixed and then you can get the drafting, rolling and then mixing and you get your own sliver which has got other fibers also. So, these machines would allow all this to happen. The other one is a stretch brake. So, stretch brake also have two zones. One is a stretching zone which would help to make shrinkable fibers, The other would be breaking zone, where actually fibers will be broken. So, stretching zone, like in the previous case also, may be something like this, could be something like that. Draw ratio given, stretch ratio 1 to 1.4 depending upon you changes. Temperatures based on what fiber, but if it is acrylic, you are looking at 120 degrees to 140 degrees heating to help the orientation, and of course, as it moves out, get cooled, and then it will go to the breaking zone. Now, normally when you just pull, all so many filaments can actually fail at different places. So, it could be so arbitrary that the lengths could be very different, but to ensure that it is not so wild distribution, then you may help by some system while it is being stretched to break. So, then if you have this type of thing, then it helps to break around the same point to get the staple length close to what you are interested in. Otherwise, it will be there. So, this is the kind of a arrangement that you may have. So, moderate strength elongation of a toe quality means that now you are going to be breaking it. So, if it is a very strong fiber, then obviously require a lot of stretch force, and because of that and some non-uniformity, you may have more variations. Lubrication again means the same thing, that you have enough spin finish which reduces the general friction, which is good for slippages, because as they are breaking, the filaments are going to slip against each other also. So, that is one, and the friction should be less. This is slightly lower deniers could be here compared to the previous one, where just cutting is involved. Here you have to break. So, all the machines, the motors, everything else will have to have that much power to do all this, because this is not a small filament being broken. So, the example here is one of the machines called turbo stapler, which does the stretch breaking. There are others also. So, this is another similar diagram. So, toe 1, which is to be stretched, is passing through some heating system and stretching between these two rolls. You can add another toe. So, this is the stretching zone. And this is the breaking zone. So, this is in case you are interested in shrinkable fiber, then you go through this, otherwise you do not go through this. So, all these machines have safety features also. If there are two plates between which the yarn or toe is moving, in case the machine stoppage or something, they overturn, the face turns, so that it does not get heated, because there is always heat which is there, and so which will keep on radiating and can damage the fiber. So, that is what these things will do, particularly acrylic, if you may like to know, very sensitive to heat. If everything is not happening right, then you can get. So, these features will be there in every machine which can stop it. It is not like a stenter, which nothing moves. If center stops, then it stops. So, the material that is there inside happens, whatever happens, happens. but here this is not done because you are looking at another good material. So, the breaking zone is here. If you want to add another toe, which is a non shrinkable type, which you also want to make it, then you can add somewhere here. And some equipment of this type, a polygonal shaped wedge which is rotating and pressing it. So, when it is stretching and about to break, based on this position, this becomes like a weak spot or additional stress. So, it starts breaking around this point. So, this is different in that sense that now there is no cutting, it is just breaking. So, these type of manufacturers, they say that our distribution of the staple length will be like natural fibers. Natural fibers are not of the same length, like you want to blend it with them. This is the one of the best ways. It's not, otherwise you are blending anyway, but that is what it is. So, this will not be one staple length. So, it will be a variation. The fused and sharp ends are not present here, that is what it is, because when you cut, there is first crushing and then cutting, and during that time you may get edges. The edges, if obviously will have some hindrance and final quality would have. In this case, because the stretch breaking is taking place and so much of a shear and movement between each fiber filament is going to take place, you may not need additional shuffling, debonding arrangements. You can directly take this to sliver making process, condensing and making slivers. So, you have two different types of principles. Different companies may be making based on these principles arrangements to do the toe to top conversion. So, finally, we come back to our high bulk acrylic to just revise part of it. So, we would be able to produce a shrinkable component and non shrinkable component. If the shrinkable component is very high, let us say 80% shrinkable component in that mixture. So, what will it do? It will only shrink the whole material. If it is too low, let us say 15%, 10%, it will shrink, but it will not be able to hold the rest of the fibers in place. So, the shrinkable component basically is trying to get the non-shrinkable component bend and make loops. So, it should not be less than 15 to 30%, could be close to 40%, but never more than 50%, because that does not help. Bulk is coming from the non-shrinkable component, and therefore, it cannot have larger percentage. In the yarn, when the yarn has already been made, it looks like a normal yarn. There is no bulk. So, if it is supplied to a knitter, it is supplied as it is, all right, unless and until somebody wants to make a change. So, this could be made on a woolen or a cotton system, but the twist should not be very high, because there is going to be some amount of migration which will take place. The shrinkable component finally are likely to come to the core, and if it is a very tight yarn, then this motion will not be there. Despite everything else, you may still not be able to, because what you are interested in, this shrinks, goes to the core, the other one buckles, should be able to slip out and get the bulk part of it. So, twist levels have to be relatively less, but it can't be very less, otherwise everything will be. So, somewhere around 2.5, 2.7 TM could be the one which is used. So, finally, the bulk has to be generated in the yarn, and for generating the bulk you have to heat. One can use dry heat, but steam could be one of the things. If independently the yarn in the form of hanks or whatever are to be first bulked then you separately you can do the steaming in chambers and it'll bulk, and you see immediate change in the dimensions. But people use simultaneous dyeing and bulking, because dyeing of acrylic fibers is generally done around 90 degrees plus, not boil, just less than boil. Above 80-85 degrees where the dye actually rushes. Below 80 degrees, the dye is almost not going into the fiber. There is a very, very less diffusion. So, it is a very small window under which an acrylic fiber can be dyed, but that is 85 to 95, 96 degrees. During this portion, during this period, if the yarns which are unbulked, they not only get dyed, but they will get bulked also. Simultaneously bulking and dyeing take place. The only thing that will happen is, if this was the kind of a hank before dyeing, it is going to probably become, in length it will shrink. So, the margins have to be given in that sense, because one thing which is very important is, in case during this bulking process any tension, twist, compression is there on the yarn, then this will be almost like a permanent change. The yarn should be very, very free when this bulking takes place. I suppose on the top or at the bottom there is any tension. For example, if somebody says, I am going to keep the yarn in a stretched condition like this and do the bulking, this portion will be very different from this portion, very different. So, when you open the lee, you will see there are portions which are flat, the portion, all that has happened, but bulking has happened very different way. It is like crepe fabrics production. When you produce the crepe, there should not be any non-uniformity while the crepe is being developed. Otherwise, that remains permanent, very difficult to remove. So, this dyeing anyway is very delicate way of dyeing the acrylic yarns. So, that one is done. Continuous bulking with hot air or steam means that there is a conveyor belt which is moving through steamer or through a hot air oven, and on one side there is a coiler or many coilers which are just putting the loops of the yarn to be bulked. As it goes through the conveyor from the other side, it gets bulked during the portion, less tension, and on this side you unwind the coils and make packages, right. This is the way the bulk can be generated in this high bulk yarn. It is a very popular method and very useful. So, one thing which I talked about the tension part is that if somebody says, well, re-dyeing, in India we do a lot of re-dyeing of garments or anything like that. If you tell somebody who is a local dyer that this is my acrylic thing, from lemon I want to make it deep red, re-dye, if the fellow understands the thing, he will say, I am not doing it, sir, do it yourself. Because any non-uniformity that comes, the structure is very delicate, the changes take place, and it is not the shade that is there, the shape may be different at the end of the dyeing. All right, we stop here, and this topic I think we have covered.